Okay, here we go. I didn't write what lesson this is. This is lesson 36. This is for 2 days. This is for Monday and Tuesday, but you kind of need to, if you're going to do the odds for the way the stack symbol has it, you almost have to watch this whole lesson to be able to do the lesson. Okay, this is 3 parts. Unfortunately, this will probably be a rather long lesson, but I'll try to go as fast as possible. This is angles greater than 360 degrees, sums of trigonomic functions, and Michelle's favorite boat and river problems. Okay, we have our angles. Hopefully this isn't too messy, but let's just talk about this black angle right here. This angle, you can't even read it, I don't think, is 50 degrees. 50 degrees right here. 50 degrees. We measure that from the initial side to the terminal side, is this side. So that's what you call the parts of an angle. This is the initial part where you start figuring out your degree from, and where you end is your terminal. So that makes sense, initial and terminal. This is 50 degrees. Or if you start here at your initial side, right here, and go this way to the terminal side, this would be 310 degrees. And when you add these up, when you go to the clockwise and the counterclockwise way, it's going to add up to 360 degrees. These two angles are called coterminal angles. This 50 degree one and this 310 degree one. And the definition for that is angles that differ by integer multiples of 360 degrees are called coterminal angles, or if they add up to 360 degrees. Or if they add up and they're multiples of 360 degrees, they're called coterminal angles. Now, look at this one. This is the purple one right here. And if I start at the initial side and I go around once, that'd be 360. And if I go 50 more, that angle is greater than 360. That's a 410 degree angle. So that's what they're talking about, angles greater than 360 degrees. It means you're going to go around more than one time from the initial to the terminal side. So this angle right here, this black angle, can either be 50 degrees, or it could be negative 310 degrees, or it can be 410 degrees the whole way around, or it could be negative, or you can go around multiple times, and it's going to be at so many different angles. So just keep that in mind. Okay, here's another example. Here's an orange angle. If I go from the initial side to the terminal side, it's going to be negative 50. If I go from the initial side in a negative direction around once, around twice, and a little bit more, this is going to be negative 770. And you can see negative 770 and negative 50, they're coterminal angles because if you subtract them, it's a multiple of 360. So just that's a little bit of terminology for you. Coterminal angles are the same angle but with different names. So 50 and 310 are the same angles, but they have different ones. This is negative 310. Okay, let's move on to do some problems. This one is evaluate the cosine of 135 degrees plus the tangent of 330 degrees. So it's really helpful to draw these. You can either draw them on the same coordinate system, or you can draw them on separate coordinate systems. So the first one we're going to do is the cosine of 135 degrees. So that's this red angle right here. So it's 135 degrees, and so when you figure out the cosine of it, we're going to make a triangle onto the x-axis. Remember, that's how we're going to do all of these. We're not going to draw them onto the y-axis. We're going to make a right triangle onto the x-axis. You have to figure out what's left. 180 minus 135 is 45, so we have a 45 degree angle. You're not allowed to use your calculators on these, so your answer should be with square roots in them. So cosine of 135 degrees is going to be adjacent, and look, your adjacent angle is going to be negative. The only one that's going to be positive in this quadrant is sine. So it's cosine, so it's going to be negative, and it's going to be adjacent over hypotenuse, so I put that one down. And then the tangent of 330, so that's the blue one. So I'm going to go the whole way around, and I go all but 30 degrees to hit 360, draw my triangle. Tangent is opposite over adjacent, and this one would be square root of 3, right? And this one is going to be negative. So it's going to be a negative over a positive, so it's going to be negative. And then we need to rationalize and find a common denominator to finish this problem. So let me just finish it up here. It isn't really anything new, it's just putting more together. So we have square root of 2, square root of 2, square root of 2, minus 1 over the square root of 3, square root of 3, square root of 3. You can probably almost do these in your head now. So we get negative 2 over negative square root of 2 over 2 minus square root of 3 over 3. And then to finish it off, you do need to find your common denominator for these guys. And so we have to multiply this one by 3, so it's minus 3 square root of 2 minus 3 times 2 gives you 6, so it's going to be 2 times square root of 3. And that's all there is for this. So you just have to put it draw the angle and then figure out if it's a 45-45 90 triangle or 36 to 90 triangle. Okay, I have to go back out into my computer and find the other screen for 36 part C. So hold on 1 second. I guess you're going to see all this. 36. Here you go. Alright, we're just going to try one more. Looks like I already started this one. So evaluate the cosine of 570. So these are angles bigger than 360 plus the sine of negative 765. So before I even drew these angles, I subtracted 360 from the big angle. I see it's bigger than 360, so I'm going to subtract 360 from it and I get 210. So 210 is going to be this angle right here. Right here is your 210. There's our 210 angle. So that's going to give us 30 degrees in here. I couldn't really fit it, but that goes right in there. And then my negative 765. Well, here I'm going to start this one from, I don't think I quite drew this right, but we're going to start from here because it's negative. I'm going to go around once, I'm going to go around twice, and what I have left is 45. So this is our 45 degree angle, and then we would construct our triangle from it, our right triangle. And we're going to, if this is 30 degrees and we want the cosine, it's going to be adjacent, which is going to be negative, over hypotenuse. And hopefully I got that one right there. Hold on a second. I think I skipped many of these in your book, so if you don't get this, which I think you will get, you can go look at examples in your book. So that one's going to end up being negative. That's just like what I thought, because you have this is going to be negative square root of 3 over 2, which I've already rationalized that just to make it easier for you. And then this one is going to be sine is opposite, and that would be negative 1 over hypotenuse square root of 2. I guess that other one didn't need to rationalize, so square root of 2. We have to rationalize these things, and so we get negative square root of 3 over 2 minus square root of 2 over 2. And so that looks like you can't do anything else to that except for write negative square root of 3 minus the square root of 2 over 2. Alright, last part of this lesson is boat in the river problems, except this one's not a boat in the river, it's a plane in the air, but you treat it the same way. Hopefully you remember these from Algebra 2. Here we go. These are our formulas for that. Downstream, so these are boat in the water problems. If you're an airplane, you're going to have wind. So it will be A for airplane and W for wind. So just keep in mind that rate times time equals distance, or distance equals rate times time. T, D stands for time downstream. TU stands for time upstream. The rate, it's whatever the rate the boat is. If you're going downstream, you add the water current to it. So this is all just your rate. The boat and then the water rate. You add those together. And if you're going upstream, you have to subtract off the rate of the water. So this is just rate times time equals distance, and that's the formula we're going to use. So we're going to flip through these. So let's look at this one. It's an airplane one. I'll try to get this so you can see it a little bit here. One day Selby found, I do believe it's Selby and not Shelby, Selby found that her plane could fly at 5 times the speed of wind. She flew 396 miles downwind for a half an hour, more than it took her to fly 132 miles upwind. What was the speed of her plane in still air, and what was the speed of the wind? So here we go. I told you have to replace the B for boat instead with A for airplane. So downwind is the airplane plus the wind, because the wind's going to be pushing her times her time, equals the distance downwind. And then this is going to be the speed of the airplane minus the speed of the wind, and that will be time upstream equals the distance upwind. Now let's read what we have, and then we write everything that we have down first before we pop them into the equations. So this problem takes a little bit of time, unfortunately. Her plane could fly at 5 times the speed of wind. So the rate is equals 5 times the wind going upwind. 5 times her. If she then the distance. They're actually giving you the distance. They don't usually do that. Well, I guess they do. So the distance downwind is 396, and then it says she flew downwind in half an hour more than it took her to fly 132 upwind. So the time downwind equals the time upwind plus a half, and the distance upwind equals 132. So we're going to write 2 equations with 2 unknowns, and I know I didn't leave enough space to do this problem. So let me just at least get it set up for you. So we can just start substituting things in. Let's see. So we're going to substitute this in. This is the rate of the airplane. So we're going to have 5 times the wind plus the wind times the time downwind equals, it would be times time downwind equals the time upwind plus a half, and that's all going to give us 396. And then we have to do the upwind equation. So it will be the same thing. This time the rate of the airplane is 5W. This time we're going to subtract off the wind. The time is going to be just the time, that's the variable we're going to leave in here, equals 132. So if we simplify these 2 equations, this is going to be 6W, and this is going to be 4W, and we're going to get 2 equations. This is going to be 6W TU plus 6W times a half is 3W equals not 396, and this one's going to be 4TU, this one's a little bit simpler, equals 132. We can solve for TU. No, I lost my W. 4W. Yeah, 4W TU equals 132. And I can get WTU, these variables can drive you crazy, equals 33. And then we can just substitute this WTU right here. There's a WTU right there. So we're going to take 6 times 33 plus 3W equals 396. And if we just solve that now for W, sorry for running out of room on you here. If we just solve that for W, we're going to get W equals 66 miles per hour. And then we just put, we know that A equals 5W, the rate of the airplane equals 5W, and so we're going to get the airplane equals 330 miles per hour. The main thing for these problems is what we did in Algebra 2, is you have to really make sure that you get your setup all set up by reading the information, set it all up, and then you put it in this equation and this equation, and you're going to have two equations with two unknowns. So that's it for lesson 36.